So I've already gone over significant digits for addition and subtraction. And the rules are the same whether it's addition or subtraction. Subtraction is just another form of addition. Subtraction is just adding negative numbers. Okay? So the rules are the same. You add all the numbers up or line all the numbers up vertically. Any empty slots to the right, you don't put extra zeros on there because that will be lying about precision. And any resulting digits from an empty slot in the column gets underlined to show they're rounded, they're insignificant, and then an arrow shows you're rounding off. You have to have units and species. This is called a species. Some indication of what it is you're measuring for every measurement or calculated answer if it applies. There are a few calculated answers we'll get to later in the semester, probably maybe just one, where there are no units of measurement. We'll talk about that when we get there, okay? But that's the rules for significant digits as it applies to answers in an addition or subtraction problem. Multiplication and division, we're going to do both of those at the same time because that's 90% of the kind of multiplication or division work we do in here. So what we're really doing with multiplication and division is multiplying fractions, which means you're doing both multiplication and division at the same time. So let's make up a problem here. You might not know this. Let's see, in this class, let's find what I want to do here. All right, trying to find my mouse. Can't see the mouse on the left side here. Here we go. All right. So there are, you want to write all this down, 44.0095 grams of carbon dioxide. In 1 mole of carbon dioxide. Later in the semester, we'll learn how to figure that out, and why that is. Okay. For right now, I'm just telling you this. All right. When I have a single-digit number 1 written for something like this, where there's so much of one thing in one amount of something, that means that's an infinitely significant number. Okay, it's a clue that this 1 is infinitely significant. That means I could have a decimal place with as many zeros after it as I wanted. Okay, so there's 6 significant digits here, but there's an infinite number of significant digits here. Got a question?
No,
okay, a mole. And there's 3 kinds of moles that I know of. The kind of mole you have on your skin, the kind of mole that digs holes in the ground, and there's this kind of mole. And this kind of mole in chemistry is the SI unit, the International System of Units unit, for the amount of substance, okay? That's something else you'll need to know for this unit, but it's not that big a deal right this minute, okay? So it's a very important measurement in chemistry, okay? Let's see. Let's say we have, let's ask this question. How many moles of carbon dioxide are there in? Somebody give me an amount. We're going to do a grams. How many grams? How many you want to use? okay? He wants to use 6 significant digits. Just for kicks, let's make it only 5 significant digits, okay? So instead of 0167, we're going to round that up to 017, okay? Just so we can talk about significant digits a little bit more. Fair enough? So 28.017, all right? And that's grams of carbon dioxide. All right. So a sentence like this means the following. It means that there are 44.0095 grams of carbon dioxide. And when I say in 1 mole, I can write it like this, 1 equals 1 mole of carbon dioxide. Okay? This statement, this mathematical statement is called an equality statement. An equality statement. Okay? That's important. All conversion units have an equality statement. All conversion units have an equality statement. In this class, if you have a conversion unit, you've also got to show me the equality statement. Okay? Because I want you to be clear about what an equality statement is, where it comes from, and what it's used for, so that in the future, when you have to do conversions, you have more skills, more knowledge to be able to use those in new and unusual ways. Okay? Well, if we're going to make this conversion, then we take this 28.017 grams, and for almost all the math we're going to do in here, we're going to start with this given amount over 1 grams of carbon dioxide. Okay? That 1 doesn't have any mathematical value. It has some organizational value. All right? Because if I divide by 1, it's just the same thing, right? Is it not? Okay. And then we're going to build this conversion unit from this equality statement. Now, if I put a dozen over 12, what does the fraction equal? Yeah, it equals 1. So we're going to build a conversion unit. It turns out all conversion units equal 1. So when we multiply by a conversion unit, we don't change the value, we change how it's measured. We'll talk about that more later. I'm going to take this grams of carbon dioxide here and put it on the bottom. I'm going to take the moles and put it on the top. If I multiply this by this fraction, like x's and y's in algebra, grams are going to cancel out. Carbon dioxide is going to cancel out. So if I take this number then and divide by this number, that's all I'm doing here. I've got ones here and here. I'm just dividing, right? Does that make sense to everybody? Okay. So I'm going to take this number, 28.017, and divide it by 44.0095. And I have an answer of 0.63661255. And I'm going to, the rules here are different. This is multiplication division. I take the measured or calculated number with the least digits and have my final answer with the same number of digits. This has 5, this has 6. So I want this answer to have 5 digits. You won't know this yet, but I'm going to tell you this leading 0 is not significant. 1, 2, 3, 4, 5. Those are the significant digits. Underline this, just like with addition and subtraction, draw an arrow. 0.6366 moles carbon dioxide. Okay?
You would put the 1 at the end after the 6?
No. Oh, I'm sorry. You're right. There's 5 digits, aren't there? 1. You're right. Okay. Got it. Okay? All right. So the rules for multiplication division are simply, look at all the measured and calculated numbers in the problem and match your final answer's number of digits with the least number of digits in the problem. That make sense? Okay, all right, we'll talk more about this tomorrow. You've got to finish your practice safety test, right? And I would start working on that saltwater density pre-lab, the procedures and hazards, yes.
Should that be page 6?
Huh?